So the last lesson we did, we looked at finding the point of intersection of two lines by graphing them. And we could use the slope y-intercept method, or you could use your xy-intercept method. You had to decide which one to use. So today, let's look at our conundrum. Yes, we can still solve any question like this by graphing them. But the problem is, sometimes your graphs show just within what you've graphed, it shows where the point of intersection is. And other times, even though we've graphed these two lines properly, we don't have a grid that's large enough. Now, could we have a 10 by 10 grid? Yeah, we could. We're talking when the numbers are in the thousands and the tens of thousands. That it's not realistic to try and graph it by hand. We need to have a different method. So when we look at this one, we can kind of figure out that point of intersection's at like negative, it's just after the 0.5, so negative 2.6, negative 1.3. Like, even though this isn't perfect, like, we've got a pretty good idea of what's happening. But if we could get a, we don't like it. Like, it's a pretty good idea, but we don't want to go with that. We want precise answers. Now, with this situation, the point of intersection is far away, and we can't see it. So we have to use a different set of skills, a little bit new concept, but it builds on a bunch of stuff we've already worked on. So I'm hoping it's not going to be too bad. We're going to build on one of the concepts we've already looked at. So when we're working with these types of situations, you could have lines that are very difficult to graph. They're tough. You don't want to graph them. Numbers are too big or awkward. When you're trying to find that actual solution or your point of intersection, that might be difficult to see. The solution might be difficult to find. Let's just get rid of that other difficult right there. That's what I get for putting in the words early. Okay, the point of intersection or the solution might be very far away from the origin. So we're not going to use graphing techniques all of the time. Questions would have asked you on the exam, solve this linear system or the point of intersection by graphing, solve it by substitution, which is what we're doing today, and solve it by elimination, which is what we're going to do in the next lesson. So this method is called substitution. Where am I at? This one's going to be a long one. When we're using substitution, there are a few rules we have to follow, but then it comes right back to our algebra, isolating for a variable. And my group this year is pretty strong with that. Like, we're good. So we are going to use a method called substitution, and we're going to take a variable and isolate it, which means get it by itself. And then we're going to substitute it, and so we were going to replace it in the other equation. So watch what's going on. Solve this system by substitution. We've got, the first thing we want to do is kind of those, math has the rules where they want you to do things properly. When we're doing a system, that means more than one equation. We just say, this is equation 1, this is an equation 2. It's just proper form, okay? It doesn't matter which one you sign as 1 or 2, but we always just 1 and 2, that's it. Then you're going to look at these two equations, and the first question you're going to ask yourself is there a variable that's already by itself? So I've got a 2 here, I've got a 3 here, I've got a negative 2 there, but this guy right there has a positive 1. That's what you're looking for. You want to find one of the variables. If it can be positive, you want it to be positive. But if it's not positive, that's an easy last step to fix. But you're trying to find the one that has got a numerical coefficient of 1 in front of it. So if we look at this, our first equation has a y that's got a 1 in front of it. It doesn't matter if it's x or y. It does not matter. It's nice to find one that has a 1. So what we're going to do is we're going to take our first equation and we're going to solve it for the variable that we're going to isolate for, which is the y. So I'm going to put some rules here. Rearrange. Ooh. One to say y equals. It's kind of like we've done this work. We just talked about all our y equals mx plus b. That's not actually what, see, I can't talk and write at the same time. It's not actually what I'm doing right now. It just so happens that the y had the 1. Plus y equals 6. How would we get the y by itself? We'd have to get rid of this whole thing, subtract 2x, do it to one side, subtract 2x. And then I am going to write it in the order mx plus b, only because if you ever get an option to have a variable, and this is the x is the variable, and then there's a number, it's good form, like again, math rules, where your variable of the highest degree goes first. So this is the only variable we have. It's got to go first in this math sentence. Okay, so we've rearranged it to say y equals go us. Look at us go. We did this one. We did this one. Okay, now we got to substitute it. Maybe I should do a different color for that. It into the other equation. So now number 2 gets to come into play. And my situation just happened to be things worked with equation 1 and then now we're substituting into equation 2. It can't go backwards. It can work with equation 2 and then you substitute into equation 1. So we're going to sub equation 2. No, we're not. We're going to sub, sorry about that, kids. We're going to sub this, y equals negative 2x plus 6 into equation 2. Boom. What does that mean? Well, anywhere in equation number 2 that there is a y, we're going to put in this instead. So if I look at equation 3x minus 2y equals 2, 3x minus 2y equals 2. So here's my equation. There is a y right here. There's no y's over here. There's no y's over here. Here's the y. This negative 2 is multiplying the y. That's the math that's happening. But we are going to replace the y with the equation we isolated for up here, because here it said y equals, so we're going to plug it in for y, and it's going to look like this. So the 3x stays the same, the minus 2 stays the same, but then this negative 2x plus 6 gets plopped in there where the y was, and then the equation just equals 2. And we've created, yes, more algebra, yes, more math rules that we have to follow, but not anything you haven't seen before, okay? So now, BEDMAS says we are multiplying right here, and we have to multiply by this whole coefficient. So the negative 2 has to get multiplied in there. The negative 2 has to get multiplied into there. So then we get 3x. Negative 2 times negative 2 is a positive 4x. Negative 2 times positive 6 is a negative 12 equals 2. And we've got it down to just one letter. So let's get all the x's together and then let's find out what x equals. So 3x plus 4x, that's 7x minus 12 equals 2. Let's add that. But if I do it to one side, I'll do it to the other. Whoopsies. Then we've got 7x equals 14. Last step, divide by the coefficient in front of the x. Even if it's negative, we divide by whatever it is. And then 14 divided by 7, 2. Oh yeah. So let's go back here. Whoa, no. Shoot skis. Here we go. We substituted into the other equation. Yes, we did that. Substitute the number found into the original equation. Okay. So our original equation was, now we are substituting x equals 2 into original. And that was number 1 original, which is 2x plus y equals 6. 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 So we are going to take, again, wherever we see an x, we're going to replace it with a 2, and that's coming from here. So we solved for x. Now we have to find a value for y. So we have to be able to replace the x with a number. And when we plug it in, she looks like this. 2 bracket plus y equals 6. Okay. Then, oops. 2 times 2, 4, plus y equals 6. How do we get y by itself? We have to isolate by undoing whatever this is. This is a positive 4. Let's undo it. There we go. But if you do it to one side, you do it to the other side, we get y equals 6 minus 4. Today, that is a 2. Therefore, the point of intersection is the x value that you found. Whoopsie-daisies. Oh, come on now. Don't move, don't move, don't move. Okay, this x value and this y value. And remember, when we're stating a point, it's always x before y, just like it is in the alphabet. So our x value was a positive 2, and in this case, our y value ended up being a positive 2. The last step we have to do is to check. So we just substituted the original. We did that, found the point of intersection. We need to check, verify in both equations. So check. What that means is take this x value of 2 and this y value of 2, plug them into the two equations, and see if they work out. So if I go back up to my first equation, it did it again. That first equation is 2x plus y equals 6. So 2x, oh no, I want that in blue. 2x, oh, now I forgot, plus y equals 6. I'll double check in a second. Plus y, 3x minus 2y equals 2. 3x minus 2y. 3x minus 2y equals 2. Okay, so here are our two equations, and on these equations we've got a left side and we've got a right side. Your left side happens right over here. Ha ha. The left side happens right there. Haha. This is the equal line, or the center line, I guess. And then your right side happens over here. Same concept here. All of this is your left side. There's your equal sign. And there's your right side. So the equal sign is the balance between the left and the right-hand side. what we're supposed to do is we're supposed to replace the x and the y with these two values. And when I replace them in here, if this math ends up giving me 6, then I know they work. And then when I plug in the x and the y, when I do this math, if it ends up giving me a 2, then I know I've done the right thing. So that's what it means to check your work, because you have to check that left side equals right side. So we're going to take blue. We're going to show that, and then I'm saying it's a green X because she came from over here, plus it's a green Y. Oopsies, I actually put an X in here, didn't I? Haha, those watching the video will see it, but those that just look at the page won't. So most of you won't. Okay, equals 6. 4, 2 times 2, 4, plus 2, 6. 6 gives us 6. Yaha! Left side equals right side. That's another like math rule that you're saying, yeah, it worked. Okay, let's do it for this one too. Wherever we see an X, we're putting in a 2. Wherever we see a Y, we're putting in a 2. 3, 2, minus 2. 2 is supposed to equal 2. So 3 times 2, 6. Negative 2 times 2 is a negative 4 equals 2. 6 minus 4, 2 equals 2. Look at this. The left side equaled the right side. It worked out. Left side equals the right side. So when a question asks you to check your work, they just want you to take the answer that you found and go substitute it back into the equations.